Howdy, I'm John Richmond, and I'm the inventor and the manufacturer of the Sluice Goose Industries GOLDROP, gold and ore separating processor. Today's video is a documentation of a test that I am participating in. This test is sponsored by Mercury Free Mining with ore sent from Peru through the Alliance for Responsible Mining to test devices here in the United States to see what devices can help eliminate the use of mercury to recover the gold in the artisanal mining community. This test is being financed by the Gemological Institute of America. So I have received 6 samples of ore from Peruvian mines that I will be classifying through a 6 mesh, a 10 mesh, and a 35 mesh screen, and then processing each classification through the GOLDROP to see what gold I can recover. To start the procedure, we'll flush the GOLDROP of any debris, gold, and ore that might still be stuck in hidden places inside the GOLDROP. So what I'll do is I'll remove the magnet sluice, invert the discharge pipe vertically, and then add on this pipe here. When I turn on the water now, the entire GOLDROP will fill up to the funnel level, so that when I open the valve, when it's fully full, it'll flush out any of the gold and the pay dirt that might be trapped in some unknown place inside the GOLDROP. So let's get to doing that. Close the valve here, turn on the water to fill it up. It's filling up now. Now the funnel is starting to fill up and the pipe is starting to fill up. When the pipe overflows, I'll open the valve and drain the entire system into the bucket down there, flushing out any of the debris and the gold that still might be trapped. There it is. Open it up. Turn off the water and let her drain. That should thoroughly flush out the GOLDROP. I will flush it out each time I run a classification. That way there will be no confusion as to what gold came out of what class. To start processing, I have the drop water meter set at 0.3 gallons per minute, vertical flow, and then the mixing valve is set about halfway open to get a mixing in action in the trap. So now we'll go ahead and start with the minus 35 mesh material and introduce a little bit of this ore in the GOLDROP to see where our setting is going to be. So there we have some of the sand in the GOLDROP, and now we'll set the elutriation water. We'll bring it down to allow that mineral to drop down into the drop tube, and actually I'm going to set it where the mineral comes to right down on top of the entrance of the water, the vertical flow. And then that way then we'll get the most gold dropping out into the jar. If we get a little bit of mineral dropping in the jar too, not a big deal. So I'm saying that's going to be our initial setting, and that looks to be about 0.15 gallons per minute vertical flow through the drop tube. So now we're set. We're going to run through and extract our gold. Let's see what's in the jar. So I'll turn up the water flow in the drop tube, keep all the dirt up in the trap, so when we close the valve, we're not trapping any dirt in the valve. Close the valve, unscrew the jar, well, I'm going to have to clean this up and see. Okay, here's the gold that was recovered in that minus 35 mesh, sand, some pretty small gold there. So now I'll go ahead and process the, well, this would be the 35 mesh to 10 mesh and see what gold we recover. Upon further processing of the 10 to 35 mesh and the 6 to 10 mesh, there was no additional gold. This is the gold, the flour gold captured by the magnetite in the magnet sluice. Pretty small stuff. This is gold more than likely beyond the reach of Mercury to recover. This is approximately, well, my guess is 250 to 300 mesh gold, and less and more. So anyway, not much gold in that 15 pounds of dirt, but 15 pounds of dirt with that tiny gold, I don't think Mercury would get all of that, but the GOLDROP can. Well, thanks for being interested, and thanks for watching.